Hi viewers, I am Damodaran. Welcome to this video lecture. Four-square theorem is the starting point of world famous variance problem. The theorem states that every positive integer can be written as sum of four squares. The great mathematician Lagrange provided the proof of the theorem in 1770. Later on, different versions of the proof were available. Hurwitz used quaternions to prove the theorem. To prove the theorem using Hurwitz ring, one needs to know about the characterization of left ideals in Hurwitz ring. In this video, we will learn about the structure of left ideals in Hurwitz ring. Let us go to the session. Characterization of left ideals in H. Here H is the Hurwitz ring of integral quaternions. This result helps us to study the behavior of left ideals in Hurwitz ring. Look at the statement. If we take any left ideal in H, Hurwitz ring of integral quaternions, then it is always possible to find an element U belongs to L such that every element in L can be written as a left multiple of U. That is what this characterization says. This characterization is very much useful in proving four-square theorem. Okay. Now let us go to the proof. We are taking L as left ideal of H. There are two possibilities. This L may consist of only one element 0 or it may consist of non-zero elements also. In case if it is having only 0 as the element, then by taking U equal to 0, we can see that every element of L is a left multiple of U. Therefore, the theorem is automatically true in the case when L is a singleton set 0. So now we are taking the next case, L not equal to 0. That means L has non-zero elements also. Okay, let us take one such non-zero element L. Let L be a non-zero element of L. Because L is a left ideal of H, L is a subset of H. Therefore, any element in L is an element of H. That says L belongs to H. And for any element in H, its norm is a positive integer. Therefore, n of L is a positive integer. So for each such non-zero element in L, we will get a positive integer. Among all those positive integers, we take the minimum. So that helps us to choose a non-zero element U belongs to L such that n of U is minimal among norms of non-zero elements of L. So what we are trying to say is, suppose if V is a non-zero element of L, then when you compare n of U and n of V, then n of U is lesser than or equal to n of V. That is the meaning of that. Okay. Now let us take an element X belongs to L. Already U is in L. We have chosen U in L. Therefore, both X comma U are in L. Right. Because L is left ideal of H, L is a subset of H. Therefore, every element of L is an element of H, implies X comma U belongs to H. Now, we are going to make use of the left division algorithm of Hurwitz ring. It says if you have two elements in H, here the elements are X and U, then we can always find another pair of elements C comma D which is also in H such that X can be written as Cu plus D with the condition that n of D is less than n of U. Okay. Now U belongs to L, C belongs to H. and L is a left ideal of H, that puts Cu in L. So Cu is an element of L. Already X is in L. Already X is in L. Now Cu is in L. Because these are in L, the difference is also in L. Because it is an ideal. But what is X minus Cu? From this, X minus Cu is simply D. So we get D belongs to L. Okay. Now by the choice of U, how we chosen U? N of U is the minimum norm among all the norms. But here we are getting N of D is less than N of U. N of D is a smaller number than N of U, which is not possible. This is possible only if this N of D is 0. So N of D becomes 0. If norm of an element is 0, then the element itself is 0 from the properties of norm, which gets D equal to 0. So ultimately D becomes 0. When D becomes 0, what happens to X from this? X is simply Cu. So X is Cu. You can see that X is Cu. Therefore, what is X? X is general element of L. So if you take any general element of L, that can always be written as left multiple of U. That can always be written as left multiple of U. Therefore, every element in L is a left multiple of U. That completes the proof of theorem. This is very important result which is used to prove 4 square theorem. I hope you would have understood this proof, the characterization of left ideals in Hurwitz ring. Thank you.